Alright, for this problem we have a geometric distribution with parameter p. This is a two-part problem. Figure out the probability that x is greater than n, and then let's figure out this conditional probability and show that it's the same as probability that x is equal to k. Alright, so first off, the probability that x is greater than n, that is equal to the sum of k equals n plus 1 to infinity of p times q to the k minus 1. That's the probability associated for a geometric distribution, and we're going to add this up for values of x that are bigger than n, so n plus 1 to infinity. Let me write this out in full so we can see what this looks like. So if I start plugging in, I get p times q to the n plus p times q to the n plus 1 plus p times q to the n plus 2, and so on. So this is an infinite series. Now this is an infinite series that is also an infinite geometric series. And over here on the side, let's remind ourselves of this formula. If I have a plus ar squared, then this infinite geometric series is equal to a over 1 minus r, and of course the standard condition is that the common ratio is somewhere between -1 and +1. Alright, for this problem, the first term is p times q to the n, and the common ratio, the thing that gets multiplied as you go from one term to the next, I'm multiplying by an extra q as I go from one term to the next. So multiply this by q, I get this term. If I multiply that by q, I get this term. If I multiply that by q, I get the next term, and so on. So 1 minus q. Now 1 minus q, of course, is the exact same thing as p, and so that is equal to q to the n. So the probability that x is greater than n is equal to q to the n. Now for the second part of the problem, we're asked to find the probability that capital X is equal to n plus k, given that x is greater than n. So this is the second part of the problem. Okay, so by definition of conditional probability, that's the probability that both events happen, probability that x is equal to n plus k, intersect the probability that intersect x greater than n, divided by the probability that x is greater than n. Alright, now the numerator is redundant. If x is equal to n plus k, and k is bigger than 1, if x is equal to n plus k and k is positive, then clearly x is greater than n. So this intersection here is redundant, and so for this problem, the intersection can be simply dropped in favor of the smaller event. And the denominator stays put. Now this does not happen for all problems. This only happens in this problem because this first event is a subset of the second event. Okay, now the chance that x is equal to n plus k, that's equal to the p times q to the n plus k minus 1. Okay, divided by the probability that x is greater than n, which we just got done showing is equal to q to the n. Now this simplifies as p times q to the x minus 1, canceling the p, or I'm sorry, canceling the q to the n that appears top and bottom. And that is the formula for the probability of a geometric random variable if there are that the first success happens on the kth event. And so the chance that x is equal to n plus k, given that x is greater than n, is equal to the probability that x equals k. Okay, so that's the formal way of writing this. Now, common sense says that this is the right answer. Suppose that I have a geometric random variable. So I'm waiting for the first success to happen. I do it the first time, the second time, the third time, the fourth time, and I'm waiting for the first success to happen. Suppose that I've done the first n successes, or I suppose I've done the first n trials, and I've not had a success yet. X is greater than n. If I do the first n trials and I've not had a success yet, if I know that has happened, then it's kind of like restarting the clock. The chance that the first success that happens at n plus k is kind of like starting over from scratch and waiting for the first success to appear on the kth attempt. So it makes sense. If I've had n attempts already and no successes yet, then the chance that the first success happens at the n plus kth time is like starting over and then waiting for the first success to start n time k without the condition.